Hey guys, welcome back. We're going to continue talking about the Pythagorean theorem today. This should be another quick lesson for you. So just to review real quick, remember this should already be in your notes. It says, in any right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. In other words, a squared, this value right here, plus b squared equals c squared. And really what that's saying here is that if I take this value and square it in terms of an area, there's a lot of different proofs to the Pythagorean theorem, but one of them that is used is this. If I draw squares off the side of all these using the side length of the triangle to make the side length of my squares, the area of this particular square plus this particular square, this space and this space all added together equal this space. So that's what the Pythagorean theorem states. It's a very useful theorem. We'll talk about it a few times throughout the year. So this is something that you'll want to make sure that you are paying attention to and that you know really well. All right, so our first example problem, you want to copy this down, is how to find the missing leg length of a triangle. So here I have this side across or opposite of the right angle is called the hypotenuse. It is always the longest side, and it is always C. Okay, so if I think about the Pythagorean theorem, remember it's a squared plus b squared equals c squared. Well, this part they tell me is b, so that must mean this is a because the hypotenuse is always c. So I substitute these values into the Pythagorean theorem. So I have 9 squared plus b squared equals 15 squared. And now I have an equation that I need to go through and solve. So this first part, 9 squared is 81. Plus b squared equals, this squared is 225. And then from there I need to isolate the b, so I'm going to subtract 81 from both sides. And I get b squared equals, what is that here? Looks like it's 44, 64. Let me double check on this. 144. I was way off. All right, so b squared equals 144. And then from here, we already looked at this in section 2 of this chapter. In order to find this, I take the square root of both of these sides. So b equals, the square root of 144 is 12. So that is the solution right there. So on the other ones that we are looking at from section 4, we are adding the values. But on this one, you end up subtracting these perfect squares. Otherwise, everything else is pretty much the same. So here is one for you to try. The hypotenuse of a right triangle is 20.2 feet long. One leg is 12.6. Find the length of the other to the nearest tenth. Okay, so make sure that you pause and you try this problem on your own. And hopefully you found your solution to be 15.8. If you're rounding correctly, it's 15.8, and it could be A or B is approximately that. So if you didn't get that right, go back and check. You made a mistake somewhere, try to figure it out. All right, so here is applying the Pythagorean theorem. It says satellites that relay television signals to Earth cruise at a distance of about 22,200 miles above the Earth's surface. The radius of Earth is about 4,000 miles. Find the distance A from the satellite to point T in the diagram, round to the nearest 100 miles. So here you can see this creates a right angle. This, by the way, is called, this line that goes from the satellite to here, touches a point right here and it would continue on. This is called a tangent line. You deal with that later when you get into geometry and trigonometry and possibly even calculus, depending on how far you take up math. Okay, so I know that this length right here is 4,000. This is 22,200. So I'm going to set this up, and I'm looking for length A. So put this into the Pythagorean theorem. A squared plus b squared. But instead of writing b squared, I'm going to write 4,000 squared equals 22,200. 200 squared. Now these are going to be some pretty large numbers. Let's see, 4,000 squared is going to be a squared plus, and it is 16 with 6 zeros behind it, so 16 million. Again, that's quite a large number, equals, and this one's even bigger, 49, 28, 4, and then it's going to be, I'm going over the picture, I know that, but you can figure it out. All right, so there's my equation. Now I got to subtract these values from both sides. 6. And after I subtract that, you end up getting a squared equals 4768.4. Hold on, that can't be right. No, that is right. Let's keep going here. And then from here, I need to find the square root of this. This is where, I mean, I'm using a calculator right now, and you should too on this. So this, the square root of that value is A is, the calculator gives me 21836.66641, but it says right here to round to the nearest 100 miles, which means I'm rounding to this place, so I got to look at this one. So this is approximately 21,000 miles, 21,800 miles. All right, so that's kind of a lot to that. And don't let those big numbers intimidate you. The rules and the way that we go through this problem is exactly the same as the problem we were looking at before. Just make sure you give yourself plenty of space. As you can see here, I did not have plenty of space, and it's kind of sloppy looking. But hopefully you followed along. If you have questions about this particular problem, make sure you ask me in class about it. Here's one for you to try. Take a moment and do this one on your own. And hopefully when you're done, you found that the height of the house is 17 3/10 of a foot when you round correctly. And if you didn't get that, go back and try to find your mistake. That is it for today. Another short lesson, so I'll see you guys in class.